Hello and welcome to the session on basic electric circuits. Today we will be discussing on the week 3 of the course, week 3 topics. So let's start today's session with one question, that is what do you mean by homogeneity? When do we say a system is homogeneous? Anyone? You can also comment your answer in the chat box. Okay, so uniform structure. Can you please elaborate a bit? What do you mean by uniform structure? Hello, I am audible. Hello. Okay, so yeah, Kishore, please elaborate a bit. What do you mean by uniform structure? No, that's not the thing. Homogeneous system is something. So if you consider a system, okay, what comes to your mind when I say a system? What it comprises of? As I say a system, it must have an input and an output, right? What I mean is let the input be let's say in the input is x, we are denoting it by the variable x, we are denoting the output by some variable y, and we are saying the system to be some f. So this can be represented mathematically as y equals to f of x. So a homogeneous system is such a system. So if you have a x input, you will get a y output for a function or a system f. A homogeneous system is such a system, if you multiply some alpha with the input, the output that you obtain will also be alpha times y for all alpha belonging to real number, and not real number, real and also imaginary, all forms of best way to write it is all, it can be any number. So is it clear what a homogeneous system is? Wait. Oh, I forgot to share my screen. Is my screen visible? Hello, is my screen I forgot to share the screen, so now is it visible? Okay, so yeah, so basically homogeneous system, if we consider system, we have an input and we have a output of the system. Let the input be x, the output be y, and let's represent the system with the function f. So we can put it mathematically as y equals to fx. So if we multiply some alpha scalar with the input, we should also get the same scalar multiplied with the output if the system is homogeneous. Okay, so this is the definition of a homogeneous system. Is it clear? So next is what is a linear system? Anyone? What do you mean by linear system?
Hello.
हाँ
Sir, if we give input to a system like xt, we will
हाँ
get output as yt. And if
YT
we multiply that xt with a certain quantity like a, so output will be
Mul
similar to a.
multiplied with the same quantity A if it's a
Multiply
homogeneous system.
with some, but sir, linearity property also satisfies this thing.
Exactly. So I'm coming to that. So
Yeah.
linear, for in case of linear system, it the system must be homogeneous. Homogeneous, and it should also satisfy another property known as superposition. Right. So all linear systems are homogeneous systems. You are absolutely correct. But it's not the other way around. Am I clear? I mean, do you still have doubt?
No, sir. No, sir.
Okay. So now linear system satisfies the property of superposition, and it's also homogeneous. So basically, if you have a linear system, let's say a system, it has an output and there is an input. Now the inputs are denoted by x and the output denoted by y. The function is represented by function f. So we can say, let's say y1 is equals to f of x1. For x1 input, the output is y1. y2 is the output when the input is x2. So for linear system, for a homogeneous system, what could we say? We could say that then alpha y1 will be the output for the input. Let's say alpha 1 y1 will be the output for the input alpha 1 x1, alpha 2 y2 will be the output for the input alpha 2 x2. What superposition principle states that we can now write y1 plus y2 will be equals to the f of alpha 1 sorry it will be alpha 1 y1 plus alpha 2 y2 should be equals to the function of alpha 1 x1 plus alpha 2 x2. Is it clear or any doubt? So that's the difference. All linear systems are homogeneous systems, so it satisfies alpha 1 y1 will be it's a function of alpha 1 x1, alpha 2 y2 is a function of is the output of the system when alpha 2 x2 is the input. But when the input is alpha 1 x1 plus alpha 2 x2, the output will be alpha 1 y1 plus alpha 2 y2. So this is the property of superposition. When the system satisfies both homogeneity and the property of superposition, we call it to be a linear system. Okay. So let's go for the next thing, that is okay. So We just discussed about what is homogeneous principle of homogeneity, and the principle of superposition. So Rizwan, since you now joined, let me just quickly recap what I have discussed. I basically discussed what is the property of homogeneity and superposition. So property of homogeneous system, it states that a system is associated with the input and the output. So we can mathematically write it as y equals to fx, where x is the input, y is the output. Homogeneous system, for homogeneous system, if we multiply a scalar alpha with the input, the output will be also alpha times y. So this is a where alpha is a scalar quantity. So this is the definition of a homogeneous system. And linear system is such a system that satisfies the property of homogeneity, that it satisfies this above property. So if we have input x1, the output is y1, and the input x2, the output is y2. Since it satisfies homogeneity, if we give a input of alpha 1 x1, it will give a output of alpha 1 y1, and if we give an input of alpha 2 x2, we will get output of alpha 2 y2. But linear system also satisfies the property of superposition, where we can say that if we give an input of alpha 1 x1 plus alpha 2 x2, then the output will be again the addition of the output of the previous two outputs, that is alpha 1 y1 plus alpha 2 y2. So is it clear, the new students who have joined right now? Any doubt? You can just comment in the chat box. Okay, so I don't think you have a doubt, so let's move to the next point. Let me give a let's say characteristics is of the form y equals mx. Alright, so is it a homogeneous system? Just answer in yes or no in the comment, in the chat box. Y equals to mx, where x is the input, y is the output. It's a characteristic of the system. M is a constant. Is it a homogeneous system? Why no?
Hello.
Huh.
Sir, because y, you said y that is equal to mx, not output will be equal to mx. So what input you are supplying?
Input is x.
Input is x. So if we multiply m with the quantity m, the output should be my.
If you multiply, no, I am saying the system is represented in the form of y equals to mx.
Yes sir, that I understand, but I think it's not a homogeneous system.
Why not?
Maybe I may be wrong, but
yeah. No issue, just say it.
Because sir, if you supply input is x and we are getting output as y, and if you multiply a certain scalar quantity like m, the output should be my, but here output is that is equal to mx, y is that is equal to mx.
No, you are confusing with the scalars, right? So m is the characteristic of the system. So there's any input you give, x1, x2. So if I give an input of say x1, so y1 is my output, so it will be m times x1.
Yes sir.
Okay.
Right? Yes sir.
Now what does homogeneity says? If we multiply the scalar with the input, so m into, let's say, alpha 1 x1.
Yes sir.
I multiply. So what I can write? Alpha 1 into m x1.
Yes sir, okay sir, okay.
So I can write it to be alpha 1 y1.
Yes sir, okay. I confused with that M
Okay,
scalar
no
quantity.
issue. Okay, so now it's okay? No confusion?
No sir, no confusion.
Others, please say anything if you have a confusion or not. Any doubt? Okay, so it's a homogeneous system. Good. Is it a linear system? So homogeneous.
Yes sir, it is a linear system.
Yeah. Why it is a linear system?
Sir, first thing is that you satisfy the property of homogeneity, and you just now said that the homogeneous system is also linear. Linear system is also homogeneous system.
Huh? Linear system also has another property. Does it satisfy? Linear system, as I just now discussed, it has two properties. One is the property of homogeneity, which is homogeneous system. Another is the property of superposition. So let's do it together. So
Yes,
let's say
sir.
y1 is the output for input of x1. Okay, so according to homogeneity, I should get alpha 1 y1 should be equals to, okay, excellent. Let me move it. Okay, should be equal to m alpha 1 x1. Now let's say another output is y2 for an input of x2. So if we apply homogeneity, because it's a homogeneous system, it's alpha 2 y2 is equals to alpha 2 m x2 or m alpha 2 x2. It's the multiplication, so I can write it either ways.
Yes sir.
Now let's add them, these two quantities. So alpha 1 y1 plus alpha 2 y2 equals, what can I get? M alpha 1 x1 plus m alpha 2 x2. So I can take m common, and collecting the terms I get alpha 1 x1 plus alpha 2 x2. So if it's my new input x3, this is my new output y3. So it satisfies the property of superposition as well.
Yes sir.
Okay, so it is a linear system, we can say it now.
Yes sir.
Okay, others, do you have any doubt if it's a linear system or not? Okay, so next is let's go to the next system. My new system is y equals mx plus c. M and c are constant. Is it a linear system? Well, x is the input, y is the output, and m and c are constants that depend on the parameters of the system. This is the characteristic of the system. Y equals to mx plus c. X is the input, y is the output. So is it a linear system? Anyone?
Sir, it is not a linear system.
It is not a linear system.
Because sir,
Say it.
if we take the input quantity as x and multiply with certain constant, we will get
Exactly.
output that is equal to max plus c.
Yeah,
But if we multiply the output with same quantity, then we will get max plus ca.
exactly.
So that
So
will not be linear.
that
To both
those two are not at all the same
not
thing.
equal, not equal, not equal, sir.
Exactly. So it doesn't satisfy the property of homogeneity, and hence it doesn't satisfy. It is not a linear
Linearity.
system.
Yes, sir.
Okay, good. Absolutely correct. So this is not a linear system. Okay. Okay, so the next is, okay, we discussed superposition. So let's take this system y equals uh, mx oh, just a second. um, huh. Y equals to dx by dt. Is it a linear system? X is the input, y is the output. The relationship between them is differentiation. Is it a linear system? Anyone? Vicky, why no? You can just comment in the chat box. Yeah, anyone wants to try? Anything that comes to your mind, please say.
Hello, hello.
Yeah, Bharat, go ahead.
Sir, if we multiply input with again same quantity A, if we take the differential of that, because output will be the differential of the input. So
Exactly.
differential, if we take the differential, it comes out to be 1 by A dA xt.
1 by A. You are saying, so okay, we are multiplying A with the input. So let's
Yes, sir.
multiply
Yes.
Ax d of derivative of Ax.
Derivative of yes, sir.
So what is the derivative?
Sir, it comes out to be 1 by A dA xt.
How it is 1 by A? The A comes out directly, it's constant, right?
Yes, sir. Okay. Sorry, sir. Sorry. I commit a mistake.
No issue, no issue. So the A comes out directly, so it's dx by dt.
Yes, sir. Yes, sir.
Yeah.
Yes,
So,
sir. And if you multiply the output
so
y
it's
with
ay only.
ay only and a dxt.
Exactly. So it is a homogeneous system.
Yes, sir.
Okay. So it's a homogeneous system. Now, is it a does it satisfy the property of superposition? Do it in the same way. Yeah. Do it. No hurry. Just multiply, just take two input and corresponding to outputs, multiply with two different scalars and just add them and see if it's the function of the addition of that linear combination of the inputs.
Hello. Yes, sir. It satisfies superposition also.
Yeah. So it also satisfies superposition. For those of you who didn't understand, let me do it for them once again. Y1 equals to d of x1 by dt and y2 will be d of x2 by dt. So if we consider homogeneity, it is alpha 1 y1 equals to d of alpha 1 d of x1 by dt and from here again, here if we multiply x2 with alpha 2, we will get alpha 2 y2 equals to alpha 2 dx2 by dt. Now let's add them together. So we get alpha 1 y1 plus alpha 2 y2 equals to alpha 1 dx1 by dt plus alpha 2 dx2 by dt. So if we just clump them together, so we get alpha 1 d of dt of alpha 1 x1 plus alpha 2 x2. So it also satisfies superposition. It satisfies homogeneity principle and it satisfies superposition. So hence it is a linear system. So a homogeneous system is something when you multiply a scalar quantity in the input, the same scalar quantity is also multiplied at the output, if it's a linear system, it should be a homogeneous system. Along with that, it should also satisfy the property of superposition. Okay, so it's clear now all?
Yes sir.
Okay, so now let's move on to the next topic. So the next topic is Thevenin's theorem. So it is basically a theorem. So it basically states that you have a very large circuit. All right, so for that circuit, you just have a output resistance or a output load. Let's say a resistance of R. You don't know what is the circuit inside. It's a black box to you. It is a black box, so you have no idea what's inside it. You can just measure the voltage across the load resistance, that's VR, and let's say the current flowing through that resistance, say IR. Okay, so how do you model the black box? So there we have a theorem that comes to help, and that is the Thevenin's theorem. So any linear circuit, so we have just now discussed what do you mean by linear system. So in if a circuit is also a system, so if the circuit also satisfies the property of homogeneity and superposition, we say it to be a linear circuit. So it has several voltages and resistances and whatnot. If it's a huge puzzling thing, so what we can do is we can represent it by a single voltage in series with a single resistance connected across the load. That is, we need not bother what is this black box. We can just say that, look, we have a voltage V Thevenin and a series resistance R Thevenin in series and across the load. We can represent it in this form. The Thevenin theorem just states this fact. Now how does it help? So if you have a very large circuit and you don't have any idea how to proceed, so you need to you can just change this black box and write it in the form of V Thevenin and R Thevenin. Now how to find out these values of V Thevenin and R Thevenin? So to find out those values, remove this load resistance. Excuse me. So this is the resistance in series and it's connected to the load resistance. Now what you need to do is remove this load resistance. Think that the load resistance is has been removed. So what is this voltage? VR. Anyone? The load resistance has been removed. It's open. So what will be the voltage across the terminals? No current is flowing through the resistance because it is open. So what will be the voltage? VR. Anyone wants to try? What is it? How much is the voltage? It's open, so no current is flowing. Okay, so it will be equals to the Thevenin voltage only. right? Because no current is flowing, so this potential will come across these terminals. Any doubt? Okay. And how to find out the RThevenin? To find out the RThevenin, what you need to do, this will be open, the load resistance is being removed. Just short the VThevenin, or any voltage sources that are present in the black box, any voltage source, it will be shorted, and any current source will be opened, and then measured the resistance across the terminal. So that resistance is given by RThevenin. Okay, so let's do an example to understand it in a better way. What is plus minus VR? So how to proceed this kind of problems? Let us consider that this portion, let me use another ink. So this portion is black box to me, so I have to model this portion in terms of Thevenin voltage and Thevenin impedance or resistance. So let's remove the load. So let's consider this 2 ohm and 6 ohm in parallel to be the load. So let's remove the loads. So loads are now removed. So what is the voltage across these two terminals? So 5 ampere is flowing, so it cannot flow through this because this is open, so it will flow through this 5 ohm. So 5 into 5, that's 25 volts. So this is my VThevenin. And what is my RThevenin? So it's a current source, we need to open it. So the current source is opened. So what is the equivalent resistance? It's 5 ohm and it's 7 ohm. So we get RThevenin to be 12 ohms. So what we can write is, it's a voltage source of 25 volt and represented in this form, and Thevenin resistance of 12 ohms. And here we have the parallel of 6 ohm and 2 ohms. It will be how much? 12 by 8, and that is 3 by 2 ohms. So this voltage plus minus VR, it will be 25 into, it's a simple voltage divider, so it's 3 by 2 divided by 12 plus 3 by 2, this much volts. So it's 75 by 2 into 27 by 2. So it's 75 by 27 volts. Okay. Do you have any doubt regarding Thevenin's theorem?
Hello.
Yeah, Bharat, go ahead.
Sir, I want to ask you one thing. We can solve this question also like this: ki 5 ampere current is in parallel with 5 ohm. So we can convert it to the 25 volts and in series with 5 ohm resistor. So,
Exactly. I'm coming to that. That is known as source transformation.
Source transformation. That's the thing.
Exactly. So I am just this is a very simple circuit. In your assignments or in your exam, it will be much larger circuit than that.
Yes.
So I am just taking an example. So yeah, you can do it. So yeah, exactly. So what is source transformation? It actually comes from this Thevenin's theorem and another theorem we will be learning in the upcoming week, that is known as Norton's theorem.
Yes, sir.
So these two are basically source transformation of each other. So if you do source transformation of the Thevenin theorem, so Thevenin theorem says what? You can represent the black box with a voltage source, a voltage source in series with a Thevenin resistance, right? Now there is another principle to simplify our calculations. It is known as source transformation. So it basically states that, so if you have this Thevenin equivalent, so you can convert it into a equivalent current source in parallel to the Thevenin resistance, and the current source will be VTH by RTH. This is basically what source transformation is. Any doubt? Anyone?
No, sir.
Okay. So yeah, let's do a problem that combines the concept that basically deals with the concept of source transformation. So here is a problem. So let's say we have here, say, okay, so let's say here we have 12 volts, and let's say here I have 5 ampere. So this kind of problem we need to do KCL of this node and KVL of this loop, so it can be made easier by source transformation. So 12 volt, 12 ohm, let's take this portion. So this part of the circuit is basically a Thevenin equivalent circuit, we can say. So we can do the source transformation. So I am transforming it into a 12 volt by, so it's a 1 ampere, 12 by 12 in parallel with 12 ohms, and you have another eight ohms in parallel, and there is 5 ampere. So now the problem is much more easier. So in order to calculate the voltage across this 8 ohm, what we need to do is the same voltage will be across 12 ohm. So the effective current that is flowing is the answer. So that it's parallel of 12 and 8, so it's 96 by 20 ohms, that is 4.8 ohms. So through 4.8 ohms 5 ampere is flowing like this, and 1 ampere is flowing in the opposite direction. So it's basically 4 amperes. So 4 into 4.8, this is the voltage across the 8 ohm resistor. So this is the beauty of source transformation. It simplifies the circuit solving. So it is very handy, and it's basically comes from this Thevenin theorem, and another theorem, that is the Norton's theorem, that will be covered in the next week course lectures. So yeah, so any doubt on source transformation?
No, sir.
Okay, others, any doubt? Okay, so yeah, so the last concept that we have is duality. Yeah, any doubt? Anyone? Okay, so the last concept that we have is the duality. So it's a very simple concept. So in my earlier videos I have discussed about the relationship between the voltage and how do we define resistance and capacitance, inductance. So the resistance comes when we say we have Ohm's law, V equals to I into R. So when the voltage across a conductor is proportional to the current flowing through the conductor, and the constant of proportionality is the resistance. Similarly, we say charge stored across two plates is the voltage across two plates into some constant that is known as the capacitance. Similarly, the flux linking through a coil is equals to the current flowing through the coil into some constant that is known as the inductance. These all these relationships can be written in the other way around. Like I can write I equals V by R. I can also write V equals to Q by C, or I equals to psi by L. Can I write or not? Hello.
Sir, screen is not visible.
Oh, screen is not visible. Okay, let me. Is it now visible?
Yes, sir. Yes, sir.
Yeah, can I write if I have from Ohm's law I have V equals to IR. I can write charge equals to CV. I can write flux linkage psi equals to Li. So from here, can I write I equals to V by R, V equals to Q by C, and I equals to psi by
Yes,
L?
sir. Yes, sir.
Okay, so let's rename these inverse quantities as something else. So let me write it as G into V. Okay.
Yes.
Okay, so I have V equals to Q by C. So V equals to, I can write 1 by C integral I dt, because
Yes,
charge is equals to integral of current.
Yes, sir. Yes, sir.
Okay. Similarly, I can write I equals to 1 by L integral V dt. Flux linkage is the integral of voltage.
Yes, sir.
Okay. So if we consider if we consider let's say these currents and voltages are sinusoidal quantities, so I can write this relation remains the same because Ohm's law is, it will be the same. So I equals to GV. This I can write to be V equals to I by omega C. I equals to V by omega L. Can I write this or not? If we consider the voltage and current to be sinusoidal quantities.
Yes sir, you can write like this.
Okay, so now comes the fun. So you have these relationships wherein we used to write so we used to write V equals to IR, I equals to omega C into V, and V equals to omega L into I. Now so this basically gives the dual circuits. How? Let me show you. So you have a voltage source in and across that voltage source we have a resistance R. Okay, is my screen visible, right?
Yes sir, visible.
Oh, okay. So this is V, this is I. I can say now I have a current source I. It's passing through a resistance R, where R is 1 by G, and the voltage across it is plus minus V. So the circuits are not same. Here it is a voltage source, here it's a current source, but the relationship is dual, right?
Yes sir.
It's the same thing. V equals to I or I equals to GV. So just I'm just changing this V with I and I with V. Okay, so now if I have raised two resistance R1 and R2, then in here it will be two the resistance will be in parallel, and it will be this is G1 and G2, sorry, this is G2, and G2 will be equals to 1 by R2, and G1 will be equals to 1 by R1. So this is the beauty of duality. So you can make another circuit just by transforming the sources and the impedances. So let's quickly just go through what can be the dual properties. So we erase that. So if the original quantity has voltage, it will, in the dual circuit it will be the current. So it can be the other way around. If the original quantity is current, it works both ways. Okay.
Yes sir.
So if the original the impedances are in series, so in dual circuit it will be in parallel. If it's resistance, it will be conductance. This G is known as conductance. If it's impedance like omega L, it will be 1 by omega L, which is known as admittance. Omega L is reactance. Basically omega L and omega C, these are reactance, 1 by omega C. So if it's reactance in the original quantity, it will be susceptance. Impedance will be admittance. Inductance will behave as capacitance, because as I said, so if you have so I can write I equals to omega CV. I can write the dual network as V equals to V equals to I by omega C. Right. Now I can write this 1 by omega c in omega c into I. Now in the dual circuit, let's change it. V will be I will be V, and let the omega c be like that. So what does it represent? It represents with this expression, I equals to V by omega L. So inductance becomes capacitance and vice versa. So this is the beauty of duality. So from one circuit you can also create another circuit using the principle of duality. So yeah, so these are the topics that are covered in this week's lecture. So any doubt in any of these topics?